right, guys, let's see if I could teach to myself. We're going to do the colligative property demos, which are on the back of the colligative properties worksheet. There's two awesome demos. Hopefully they work out. I'm really excited to try it at home. I'm actually going to start prepping the second demo first. So let's look at that one. Try and fill out, now for down at number 4, the freezing point of pure water. You should know what that is. Do it in degrees Celsius. Okay, now I have a bottle of club soda here. All right, so think about if this is pure water or a solution. All right, it's a solution. So the freezing point of this should then be higher or lower than 0 degrees Celsius. Okay, it's lower. All right. So here's my bottle. I'm going to take off the wrapper. It's a glass bottle. All right, I'm going to take off the wrapper. The freezing point of club soda, all right, is actually negative 10 degrees Celsius. So you could fill that in. Now, I want you to think about why. All right. If I get it and put it into a really cold ice bath, all right, so I have here, I took a bowl. As you can see, it's really, really cold, all the condensation on the outside. Oh my gosh, I can't even hold it. It's really, really cold. I put ice in there and a bunch of salt. I'll show you a camera in a minute. I'm going to add some more salt and get it really close to negative 8 degrees Celsius. All right, so I don't know if you can hear, but I'm putting a bunch of salt in here. So there's salt and ice, and it's a nice ice water bath salt solution. I really am getting the temperature with my thermometer there, and right now it's negative 5. If I need it to go colder and colder, I just add more and more salt. All right, so I'm going to stick and submerge the club soda, okay, into this really, really cold bath. Yes, negative 6. All right, I'm going to add all the salt I can just to give it one shot. I got one shot to make this work. So think about soda, what your solute is. Okay, it's carbon dioxide. All right, so that's why the freezing point is lower in that club soda, why it's negative 10. All right, visualize, I'm going to start screen sharing. All right, visualize your, this is my club soda, sorry, that's my drawing. And think about that there's not just water molecules in here. There's also carbon dioxide. Okay. And think about what I told you. You know, think about what's keeping the carbon dioxide in the solution right now. All right. And then I'm just going to let that sit in there. Right, and if you need to pause the video to maybe try and answer number 5 and you want to try and talk about why it's currently not freezing, you can pause it, fill that in, and then continue. All right. Okay, now I'm going to switch over, okay, to the first demo. All right. First demo, I've got a little beaker of water and food coloring. Okay, a drop of food coloring was added in there. All right. I want you to think about, all right, what is going to happen to this beaker if I put it in the freezer overnight? All right, so this is what it looks like now. All right, And then I'm going to put it into the freezer. And what I want you to do is I want you to think about, you can maybe draw your ideas of what it is going to look like the next day when you take it out of the freezer after it stays all overnight over the freezer. All right, so pause the video. Okay, so what do you think it is going to look like? I'm going to show you. I have one in the freezer now, but I could show you a picture of what it ends up looking like. Actually, let me give you a hint. Go down to number 2. All right. See if you can answer some of these questions. All right. Think about this. Think about if you were to put an ice cube tray into the freezer, would the whole ice cube freeze all together everywhere? Right? Or think about where it gets coldest first. Right? Don't you agree that, like, if you put a beaker of water in the freezer, where does it get cold first? It gets cold on the top and the sides and the bottoms and the sides there. That's where it gets coldest first. So then try and answer thus, what would freeze first, pure water or colored water? And what is easier to freeze, pure water or colored water? Pure water should be easier to freeze because there's no solute in it. The colored water, what's the solute? The food coloring. All right, and the food coloring is getting in the way of the water being able to freeze. So let me show you what it ends up looking like. All right, look at that. Isn't that awesome? That's it. I took a picture of it in the freezer, okay? And you can see that it freezes the pure water first on the outside, and then eventually it then freezes the whole thing. But the way it'll be frozen, all of the green is frozen in the center too, right? But that's the solution. It had to get colder to freeze the solution than just the pure water. Isn't it gorgeous? So I did this earlier, and I thought you might like it to see what this looks like now. So it's not totally frozen, but I think that that's the coolest thing, because it's frozen on the outside, clear, but then it's all liquid green in the middle because I didn't get a chance to freeze it overnight. I just started it this morning. This is the one from a while back. All right. So this is like the coolest thing. I made like a little cup. That would be a big fat mess. Yeah, it's a big fat mess thing. All the liquid green just kind of spilt out all over the place. All right. But you could see it's awesome. You could do this at home. You could literally just get a little cup and make a very dilute water. That's what I should have done. Just made you guys all do it and see what happens. All right, live and learn. That would have been experiment at home. See what happens. So it doesn't freeze uniformly. Okay, and then some people ask, well, how do they get like ice pops to freeze uniformly and you have the color all over? They'll flash freeze them and freeze them all quickly, all at once. Instead of, you have to freeze this slowly. This will work as long as your freezer is not too cold and it doesn't freeze way too fast. If you freeze it nice and slowly, you do get that effect of freezing just the pure water first, and then it's like, you know, screw it, I'm not going to be able to freeze all the solid, all the solute until it gets cold enough to be able to freeze the solution that you have there. All right. So if at any point you need to pause this video and before you go on to club soda, I would pause now to fill out 1, 2, and 3. All right. Make sure your drawings look good, your explanations look good as to what's going on with that demo. Okay, so let's finish up the last demo. I've had this club soda sitting in this cold ice bath. It hasn't been sitting there as long as I wanted it to, but we'll see if it works. I'm gonna try screen sharing the other way so that you can see my, I will be so excited if this demo works. If it doesn't work, I'm then just gonna have to show you a YouTube, which stinks. Okay, so here we go. What I'm gonna do is oh yeah, I'm really bad at opening it. I usually ask for a volunteer. Oh no. Let's see if I could do it. If I can't, I'll call Dennis down to try and open this thing. You know what? I'm gonna get one of those grabby things too that I have. Okay, I got one of these things. Hopefully it'll give me a good grip and help me open it. All right, but think about this. Right now, what's keeping the carbon dioxide in is the high pressure. Remember I told you at above the soda bottle, it's got very, very high pressure and it's keeping the solute in. As soon as I open this soda, the pressure should go down. So then what's going to happen to the carbon dioxide? And then if the carbon dioxide does that, what will happen to the freezing point? All right, so let's see if it works and then we'll chat about it. Okay, here we go. I opened it. Oh, it's working. Do you see it? Yes! Look, it froze. And notice how it froze. It froze from top down. All right. Because think about it. As you open it up, the gas can escape. The pressure went down. So if the gas leaves, now it's not in the way anymore of the carbon dioxide, of the soda being able to freeze. All right, because your carbon dioxide was able to escape. Oh my gosh, it's awesome. See, it's all like slushy soda. Oh my gosh. Honestly, I've never had it work out so beautifully. And it's on, I'm hoping I'm recording. I think it is. I hope my sound is on. Okay, so that's that. Okay, so hopefully you were able to understand that. Draw pictures, write it down, draw what's happening. Make sure in the bottom part of your club soda demo, you talk about and use terms like solubility, pressure, and freezing point. Say what's happening to the freezing point. Is it increasing or decreasing? High solubility means there's lots of solute. Low solubility means there's not a lot of solute. So use terms like that, talk about pressure, and get it all in there. If you have any questions, you can definitely chime in during office hours or whatever you need. But I hope you enjoyed the demo as much as I did. Okay, I can't wait to watch this back. So yeah, oh, this is the one paper that I want you to send me. Okay, that's the one paper for homework by 8 o'clock on Wednesday. All right, 8 a.m. Have a great afternoon. Bye.